Hey you guys, welcome back to the channel PHYSICSSIRJEE, and this is just a continuation video of the online course demo that I have put up in the last one. It was a kinematics, one of the lectures, right, to give students a taste of what they are going to expect in the online courses. Okay, so already 2023 crash course demo has been put up, 2024 full-length lecture demo has been put up. So this is actually another demo session for the live doubt solving. So because I'm going to launch the courses, and this is going to be the last video before the launch. I would like the students to understand what they are going to pay for. Okay, right. And also, because this is a demo video, you should not judge the type of problems that are being solved in the demo. I have chosen kinematics because most of the students might have completed kinematics and also have a comfortable nature to this particular topic. Now, when you are going through this video and looking at how the doubts from the DPPs and lectures are being solved, you should imagine yourself asking similar in-depth doubts in much tougher topics in the actual course, right? For example, fluid mechanics, surface tension, then you have waves and sound, right? And thermodynamics, electricity and magnetism, even modern physics. So try to imagine you are in that particular course and you are asking me questions and how the questions are being discussed and why the live doubt solving is a very important part of preparation of a student. Any teacher can put up any number of videos, right? Give shortcuts. I have given a lot of shortcuts in our YouTube channel, 270 odd videos, and most of them are the ones where unique problem solving methods have been discussed. So uh, the rank will be decided by the proper preparation. So tricks and doubts, tricks and shortcuts that I have put up in this particular channel may guarantee you some extra edge over other persons who are preparing. But a systematic course where lectures are taken up, then DPPs are given, then there is a planner that is going. If you see this particular video till the end, at the end you would see what kind of a weekly planner will be given to the students. And after each lecture, what work has to be done from standard books and also the printed DPPs. So all this is part of my intention to provide you with this insight into the course. Okay, right. And once this is done and the course is launched immediately, right, you would be able to take a decision whether to buy the course or not. Okay, so before we move ahead, please do subscribe to this channel if you are new. Right, a lot of quality content is part of this channel and a lot of it is free as of now, right? So please do enjoy it and try to like and share the content of the channel. Okay, and also there is a Hindi channel for the benefit of the students who are comfortable in Hindi, and the online 2023 course that is going to come will be in the mix of Hindi and English. Okay, so please do check out the channel. Link of that is in the I button above or the description below. And since this particular lecture is cut from one of the full-length lectures of kinematics, okay, not all problems are included in the demo. And just 500 likes for this particular video, and I'll launch the online courses of 2023 and 2024 you are waiting for. Okay, so I am excited. I hope you are too. Okay, so let's start off with the doubt session. So this will be the continuation video from the kinematics demo video that I have put up. So in case you have not watched it, watch that, and this would be the continuation. Okay, so let's go. So we're back again. So I'll just give you a brief of the thing. So we were looking at this problem from the 2 or 3 lectures back on the riverman situation where the river flow is non-uniform. It was given linearly varying, right? I think you can pause and see this one at a later stage to check which function it is. And the homework question that I was trying to discuss is to get the trajectory equation of the motion of the boat or the person, right? So I just said that if I assume that the person has moved at any arbitrary instant to a position in the xy plane here, he would be, or his motion would be governed by his own velocity with respect to river, which was 4v naught this way. Can you see, right? I took the 4v naught red colored vectors, 2 components separately, 2v naught and 2 root 3 v naught. And then there would be a flow of the river, which is a function of x, right? So the set of this entire vector, which is, let's say, yellow colored one, right? So yellow colored vector,
right? That would be decided by the sum of all these. Okay, so that net velocity vector, right? That net velocity vector Vx, right? Instead of writing Vx, I can write dx by dt, right? So this is the net velocity that I am writing. Okay, right? So the dx by dt there would be governed by the value of Vx minus 2 root 3 V naught. Okay, right? So I'd write this 2x V naught by d minus 2 root 3 V naught. You'd get this, right? And then dy by dt is purely governed by the 2 V naught. So it's constant. Okay, right? So taking these two and dividing them, right? Dividing, that's the way, right? Any trajectory equation by now you would have realized, whether it was parabolic trajectory of the projectile motion or anything in future. I think time is the parameter that I'll always look forward to eliminating. So the best way to eliminate this set of equations is to divide the two. Okay, so I would go with dy by dx, more traditional way. Okay, so dy by dx should be equal to 2 v naught. Can you see entirely 2 v naught will get cancelled? So I'll just write 1 divided by what would be the lower one? I could see an x by d minus root 3. This is the expression you get. Okay, so y versus x, you just integrate dy on one side, dx on the other side, x by d minus root 3. Okay, and as the integral, always we be careful with the limits. The person or the board starts at 0 comma 0. Okay, so at y is equal to 0, x has to be 0, and at any arbitrary y, x is x. So this is the way you substitute. So the value of y, therefore, upon integration gives you, I think this integral is a logarithm as an answer, right? And whenever you write log while integrating, always don't forget to put a mod in the domain, that because logarithm has to be always considered for a positive number. So if I take that, this would be d times of logarithm of mod of x by d minus root 3 as it varies from 0 to x. Okay, just don't leave it at like that, because you have to substitute 0 also in that. So the required answer would be simply d logarithm. If I substitute x, it remains the same, and if I substitute 0, it becomes minus root 3, which becomes a positive this thing. So the entire thing x by root 3d minus 1. So because you have to subtract and then it gets divided. So this would be your not so simple curve, but I think simple calculation that led to this answer. This is your answer. Remember, this is the curve valid only up till the middle. Okay, from there again it changes because the function for the velocity also changes. Okay, so this was only for, let me write it, x less than d by 2. So this was considered. Okay, right. So this was the answer for one of the homeworks. Let's go to the other one. I think it was the Tom and Jerry problem with v is equal to u being considered. Yeah, so this was the question, right? So in the previous Tom and Jerry classwork question, you have seen when v is greater than u, Tom catches up with Jerry after a finite time, which we estimated, right, as this number, right? And if v is less than u, it won't catch up. But we were looking at a homework question of a critical value of v exactly equal to u. So in that, I'll try to again draw a arbitrary instant diagram. Let me draw that arbitrary instant. So initially, both of them, let's say, start here and here. These red dots are the initial instants. Then let's suppose the Tom goes along a curved path and reaches here. And at that instant, if I extend the velocity vector of Tom in a dotted manner, wherever it hits the white line, that would be the velocity or the position of the jerry that instant. Okay, right. And some students found it slightly confusing in the last class that I used letter X for this dotted distance. Okay, I think you might have realized that. So to avoid that confusion for this particular problem, I'll try to use S this time. S is the separation for between them. Okay, I'll try to borrow the letter X for the X coordinate. Okay, so that that confusion is removed. Okay, so if I project, listen carefully to this, if I project the Tom's position, if I project the Tom's position onto the white line, which is, let's say white line is your x-axis, let's suppose this is your x-axis, easy for us to recognize that. So this would be the position there at that point. Okay, now I'll mark something. I'll mark that this gap, look at this very carefully, this gap, can you see there is a white colored arrow that I marked, right? This one I'll write this as some letter X. Okay, right. So what does that X mean? X is separation along x-axis for Tom and Jerry. Okay, so that's the definition of X. Can you see what's the initial value of X? Are Tom and Jerry separated initially? Answer is yes. The separation initially is by a distance d. Can you see that? This separation exists, yes. Right? But that is only along y direction. So if someone asks you what is the value of X initially, I think it is 0. Okay, so whose initial value is, I think you will all acknowledge, 0. So along x direction they were not separated at all. Okay, right. And I think once the Tom reaches that white line, whatever the final value is, we are supposed to find that in the question. What would be the distance? Can you read that top line in blue? That was the question. What would be the distance between Tom and Jerry after a long time? Is now nothing but we have to find the final value of X. So let me write it down. This implies we are here to find final value of X. Okay, right. If you can understand that much, I think the job becomes easy for me. So now I'll write ds by dt and dx by dt. These are the two things that I would always try to write. Okay, so the s thing, imagine I'm already using v is equal to u, so for both I'll use u only. Okay, so if u velocity for this is in this direction and the u velocity for this is in this direction, I'll mark an angle. Okay, right, let me zoom the diagram so that you can clearly see. I hope this will help now. Okay, so this angle I'll mark as theta. Can you see theta, everyone? Okay, right. So if I were to draw another white line for my reference here, can you see this white line is parallel to the x-axis? I think you'll all accept this is also theta. I don't think there is an issue there. Okay, now try to visualize. Enough of drawing the springs. We have been drawing springs. I think now you should be good enough to tell me, is S reducing in length or increasing? This dotted gap, imagine there is a spring like this. Is this spring compressing or expanding? I think you would say that it is compressing. The job of this U is to directly compress S, whereas the job of this U via a component in this direction. Can you feel that component here? In this direction, the component of that U with a vertically opposite angle of theta would be U cos theta. So if I am kind enough to again redraw that spring parallel to that red one, you would all be able to accept that this is your U for the Tom's position that compresses it, and at Jerry's position there will be a U cos theta which is trying to expand it. Okay, so this letter S, can I write ds by dt? So if I try ds by dt, right, ds by dt, that would be rate at which S is increasing. Then this would be positive term and this would be negative term. ds by dt, this will contribute with a positive one and this would be with negative one. So let me zoom out. the value of that ds by dt would be equal to ds by dt is equal to positive u cos theta minus u. Okay, so please realize that this is Jerry's contribution and this is Tom's contribution in ds by dt, just for understanding, right? I wrote those letters. Now let's see what is dx by dt. Let's go there again. Okay, now see this. Okay, for x, you realize one thing, this x length, again there should be a spring that you could draw. Okay, so I'll draw that white colored spring here. Okay, this is this spring is representing this distance. Okay, right? Now at the right end of the spring there is Jerry, okay, which is pulling it, as you could clearly see, with a direct speed of u. Can you see that? I've just borrowed this u here. Okay, now this other end, it's not Tom actually, it's a Tom's component point, right? So maybe I'll mark that as t prime. Can you see that t prime there? So that t prime is moving towards right. Can I say with a component of this u along this direction? Okay, component of u along x direction, I can mark it here. So it's compressing that. So this would be a u cos theta. So that x on the sideline, right? Can I write dx by dt? This would be the positive contribution because it's trying to increase x, and this would be the negative contribution. So I'll write that aspect there. Okay, let me zoom out with that visible to you at the top of the diagram. Can you see that? This would be equal to a u with a positive term and u cos theta with a negative term. Ironically, you could see again Jerry contributes positively and Tom contributes negatively, but this time the terms are reversed, as you could see. We all know that if I were to solve individually, I would actually hit a roadblock. I told you dead end, right? Last time, there's no way you can solve this equation by taking dt on this side, integrate, because integration cost you. But we can see and eliminate that by looking at these two equations. And this is a very special set of equation. You could see this is negative of this. This is negative of this. So these two together will yield that ds by dt is negative of dx by dt. Okay, or simply that s plus x is constant. Actually the sum of s and x distances is a constant, which is very difficult to understand right at the start, right? What it is inherently telling you is this length plus this length always remains constant, which means s reduces, x increases in such a way that sum is kept constant. Okay, so which we are going to cancel out the dt and integrate over both sides. So integration of ds should be minus integration of dx. Always map the correct limits. Okay, what's the first value of s? I think first value of s is d. Okay, I think last value of s is the same as last value of x. This final value of x and final value of s will be the same, because Tom will move on to this line and the red one will just project onto x-axis only. There won't be any y separation. So finally s value and x value will become equal to each other. So I would write that as the x final. So this should be x final. Okay, and x initial you all agreed was 0, and this has to go to x final. So this is the important equation. So here you could see the value of d minus xf is equal to, because of the minus sign, you would actually have this would be equal to xf minus 0. Okay, right? The first value is d, the final value is xf. So actually I've reversed both the equations. So instead of doing this, let's maintain the signs. Mathematically what I wrote is correct, but it would have been better if I had written final minus initial is equal to initial minus final, because of the minus sign. So which surprisingly gives you that the last separation is half of the initial. So this is your required answer. Okay, I hope you understood how we went about this problem. So finally, they will be separated by a gap of half the initial separation, and after that the separation can't change because both of them will be moving along the x-axis with zero relative velocity. When relative velocity between two of them is zero, the gap will be maintained forever. And that's what would be this. Okay. So the miracle here is this two sets. This has been adjusted in such a way that these two are actually cancelling each other, giving us this relation. That's why we were able to solve this. And remember, this actually happens after a long time. So if someone asks you after what time this happens, you would say infinite, right? So that's the thing. Okay. Fine. So let's move on to the DPP1 in that priority order. Okay, I think I have it here only. Yeah. Okay. Right. Anything in DPP1? I hope you have gone through the printing errors that I have posted already. So I was going through them and I saw some of the errors. So I thought you would be requiring them. So all these are basics of interpretation of whatever we did. So, single option, correct? DPP1. I couldn't hear you properly. Can you repeat? Is it eighth? Eighth one. Okay. A swimmer moving upstream passes a float at point P. After 2 hours, he returns, and at this instant, it meets the float again at a distance 15 km from point P. If the swimmer velocity in water remains constant, then find the speed of the river flow. Now, there is a problem, I think, here. Which is this one. I think it should not be in here. It should be with respect to water. So let me correct it. And this kind of error, lot of examiners also do. So if they write it as in water, then you should read the question and try to see whether the ambiguity can be resolved or not. Okay. So is that your doubt, or did you not get how to solve? Because similar question we have solved in the classwork while lecture was going on. So is that your doubt, or should I continue solving the problem?
I'm getting a different answer.
Okay, so let me then try to do that. So let's say the float was met at point P, okay, and I'm drawing this entire picture with respect to float. Or float is something which moves with river, right? So it is with respect to float or river, both mean the same. Okay, right. So in this frame of reference, the water is frozen. Okay, in this frame of reference, the water is frozen, and he will, or the float will see that the person is actually moving only with the V with respect to river. So he would see he goes in the forward direction and again comes back to meet. And once that happens, in how many hours? He said 2 hours. Okay, so 2 hours. I think upward motion or onward journey should be 1 hour and return journey also should be 1 hour. Okay, right. So he's saying at this instant it meets the float again at a distance of 15 kilometer from point P. So the float also goes forward with respect to ground. Float moves forward, right, for 2 hours with a speed u. So u into 2 hour should be equal to whatever 15 kilo. Array, this has nothing to do with our question actually. They direct this thing. Find the speed of the flow. So this should be 7.5 kmph. Did he give 7.5?
They gave C.
C. Okay, okay. I think there is a problem here. Because this is obvious, right? Float will just move forward for 15 kilometer for 2 hours. I think there's some misinterpretation or misprint. Okay, 7.5 is correct answer. So this first part is not even necessary actually. I thought he was asking about V, that's why I wrote this. So this should be the correct way. Right. Anything else in this page? Okay, nothing. Next page.
So
Yeah. Can you say it again? I couldn't hear.
12th.
12th. Okay, 12th. A 2-meter car is moving with a speed of 5√2 along a straight horizontal road. A boy starts crossing the road with a constant speed, he said. So very important, constant speed. When the car is 2-meter away from him. This 2-meter car, I would assume, is like a square box. He didn't mention anything, so I have to assume, because I need the width also, not just the length. Okay, so the minimum speed of the boy to car, minimum he said. So I have to consider all the possible cases. So I think you might have got stuck with the diagram here. So let me try to interpret what I read. So let's say this is your car box. Okay, and this is your road. Okay, right, and the person has to start here. Let's say the person is here. Okay, this point I mean. Okay, and then he has to cross without getting hit by this 2-meter length. So this is your 2-meter length, both in this direction and this direction. When the car is 2-meter away, so I think I need to be here at 2-meter away. So in this direction also it is a 2-meter away. So person is actually here. 5√2 car is moving. Right. Minimum speed of the boy to cross the car safely is. So one important thing that you should not do is assume person has to only cross this way, right? Because if he's trying to cross this way, he needs a different velocity as compared to any other direction also he can move. That, like, he could aim in different directions, maybe cross better in a shorter time. So what I'll do is I would try to solve this problem with respect to the car. So with respect to the car's observer, so this is all drawn with respect to car observer, right? That means I have to reverse this 5√2 and put it on the person. That's what VA minus VB means, right? So VA minus v car or velocity of the person A with respect to car is nothing but VA plus minus v car. So that's what reversing and putting means. So I'll reverse that red colored phi root 2 and put on this fellow. Okay, right. So in this frame of reference, the car is at rest, and this 5 root 2 has to be traveling at 2 meter. Okay, this 5 root 2 has to be traveling at 2 meter. So his actual velocity could be such that it could be some angle like this, so that the resultant should be along this direction. So this should be the direction of resultant. Okay, right? So the resultant should make an angle of 45 degree so that it goes in the least possible time. Okay, right? So this is it. So I'll just borrow those vectors there. This would be 5 root 2. I don't know what the angle or the direction of this is, but I know that the resultant should be making an angle of 45 degrees like this. Okay, right? So you can use the tan theta relation of a resultant of two vectors. Okay, so the value of tan 45 degrees should be equal to b sine theta by a plus b cos theta. Remember resultant rule. So the b is v sine theta, okay, right, divided by 5 root 2 plus v cos theta. So rearrange, you get v as a function of theta and minimize. So maximize, because minimum time means maximum speed. So maximize this. We'll get the answer. Is that clear, everyone? So the person who has asked the doubt, maybe the mistake you could have committed is assume that v is this way. You need not have a v this way. I think going in this direction will save more time. Okay. And you might actually, my guess is, you might actually get in the absolute direction, you might get the theta is negative actually. So this entire value, he should actually, I get a feeling that travel like this. So I didn't know that at a start. So, but the function will tell you that it will actually finally go this way. The theta will become obtuse. Anything else in this page?
13th.
13th. Two cars A and B are moving on same track in opposite direction with velocity 90 kmph and 54 kmph. So this would be 25 meter per second, and this would be 15 meter per second. Okay, right. And when separation between them becomes 225 meter, both the drivers of the car apply brakes, producing uniform deceleration in car A, while deceleration of B decreases linearly with time at a rate of, actually this is a problem. If deceleration should have a rate, this should not be the units. The units of this should be meter per second square per second. So 0.3 meter per second cube you have to take. This is that. So the value of acceleration of A, okay, right? So let me take a next page, and then I'll draw a picture for you. So there is A, there is B. I'll take this direction as positive for that problem. A was moving towards right with 25 meter per second. B is moving towards left with 15 meter per second. And at an instant when the gap between them is 225 meter, right, A started applying brakes. Remember, applying brakes, which is retardation, acceleration should be considered to be in the opposite direction of velocity. So I would say that the acceleration vector of A would be in this direction, equal to, what did he say? He said it's just uniform. Okay, minimum, that value you have to find. The minimum value of A you have to find. Okay, and what about B? Well, deceleration of B increases linearly with time at a rate of, so I'll assume that it is KT kind of a thing. Okay, and deceleration for B should be again opposite the velocity of that. So this should be k times t kind of a thing, where the value of k is 0.03 into t. 0.3 actually, not 0.3. So I'll just, so this is 3.3. So he's asking you what is the minimum acceleration before it stops. So I think first this is a determinable quantity. So let's try to visualize two possibilities. Okay, possibility one is A comes to rest first. Okay, and possibility two is B comes to rest first. So let's see the B situation first. Okay, so for B to come to rest, I can't use V is equal to U. So V is equal to U plus AT is not valid here because A is a variable. So you have to go by the normal rules of dV by dt is equal to A, which is 0.3 t. I've taken positive direction in this way, so I've substituted A is positive here. Okay, the V initial value is negative, so I'll take care of that, don't worry. So you might be wondering why I didn't put a minus sign here. I'm respecting this, so these two are in the same direction, so I've written that minus of 15 I'll acknowledge while I substitute here, so please be careful about that. So this I'll integrate on that side. So integration of dV is equal to integration of 0.3 t over time, and the care now I'll take the initial value of time when it is 0 to final instant when it will stop. Remember, the initial value of velocity is that minus 15, and finally it should stop. So this is how I'll take care of that. Okay, right. So this value would be 15 on this side. This would be 0.3 into t square divided by 2. I hope everything in SI units. Okay, so this would be 30 divided by 0.3, which is 100. So this will stop in 10 seconds. Okay, this will stop in 10 seconds. And in 10 seconds, if I calculate the distance traveled, okay, so I have to double integrate again. Instead of substituting limits, integrate again on both sides. I would have ended up having this as minus some V in some direction. So let me integrate normally. First I would get V is equal to 0.3 t minus 15. How did I write this? How did I write this? I integrated in a normal manner without the limits of 0. I put a V in general. Okay, so this would become V plus 15 on this side. This would be 0.3 or I forgot, t square by 2. This should be 0.3 t square divided by 2. Okay, sorry, and then minus 15. Right. Then integrate it again. So this would be displacement S in negative direction, whatever that happens. This should be equal to displacement is equal to integration of this is 0.3 t cube divided by 6 minus 15 t. Okay, upon integration, and I have to substitute the 10 seconds to get the value of displacement. Okay, right. So what would I expect this to be negative because the particle is moving towards left. Okay, so this would be 1000 into 3, so 300 by 6. 300 by 6 I see is a 50 when I substitute 10 seconds, and this would be minus 150. So I see a minus 100 meter displacement. So what is expected is if B were on its own, okay, so if B were on its own, it would have traveled 100 meters to stop. Okay, it would have traveled 100 meters to stop. So irrespective of that, if A were to, I need this A in such a way that if it can stop before hitting that point B, right, whether B stops after 10 seconds or 15 seconds, it doesn't matter. Then I should be able to effectively get the value of A. And for A's motion, I will be able to use V is equal to U plus AT and S is equal to UT plus half AT square. So if B is able to travel 150 in this direction. Let me check. Did I get 150? No, 100 I got. So let me manipulate this. So this was 100 and reach here after 10 seconds. Okay, in less than 10 seconds, because if it is more than 10 seconds, then also it will not be a problem, because I think once B has stopped, and if A were to reach this position in more than 10 seconds, right, then also you will end up having them not hitting each other. So I would use this also as in a critical case at 10 seconds to cover a distance of 125. So for A, in a critical case, S is equal to ut plus half at square substitution requires that 125 in a positive direction is equal to 25 times of 10 plus half into a negative value of that A that I don't know multiplied by 100. So rearranging, this would be minus 125. Could see this is minus 125 minus 250 minus 250 by 100 I am getting, which is the critical value of that. So minus 2.5 meter per second square. So this is the way you solve it. I think this is your answer. Is that clear?
Yes, sir.
Okay, right. Please, I apologize for this printing error. You might have got confused here. Okay, so that should have been by units and dimensions. You should have got it correct. Okay, next. Anything in this page? Nothing. Okay, let's move ahead. This is done. Okay. I think there was a misprint in 16. I already wrote that in your group. So
15.
15. Let's go to 15. Horse question. Okay, a horse is running with a constant acceleration g by root 3. Okay, horse is, we don't say running, we should say galloping. Okay, so fine, it doesn't matter in physics. A small ball is projected by a horse rider at an angle theta with horizontal with respect to the horse. So this is very important. Okay, or with respect to the boy also. The value of theta such that the ball again catch by the boy, ball again is caught by the boy. Okay, so I think this is pretty simple. So I can't draw the horse, so I'll assume that the boy is moving with an acceleration of g by root 3, and there is anyway the original gravity also. So what I would assume is, with respect to the boy, if I draw the motion of the ball, so whatever trajectory the particle is going to have, let's say the ball has been thrown from here into the air and it is now in the air somewhere here. Now let's see what are the acceleration components that it would have. One acceleration component anyway in any frame it will have is the reality, which is g. But I already told you, whenever you see with respect to any frame, whether it is velocity, whether it is acceleration or displacement, you need to just subtract from the original value. That means velocity of ball, or acceleration, let me write, acceleration of the ball with respect to the rider r is nothing but acceleration of the ball in general, which is g, plus a negative acceleration of the rider, which suggests that you need to reverse this g by root 3, see, addition of a negative vector. Okay, so what this person effectively sees is he reverses that g by root 3 and sees it like this. So according to this fellow, who he thinks he's at rest now, in this frame of reference he's at rest, he thinks the ball is in the air experiencing this set of vectors. I think it will reach back him if it goes in a straight line according to him. That means the velocity vector should be along the direction of the g net as seen by this guy. Okay, right. Theta with respect to horizontal, that means this angle should be given by tan theta is equal to, I see tan theta as that blue color G divided by the red colored G by root 3. So which is 60 degrees. Whenever you throw a particle in the direction of effective gravity, the motion would be a straight line. So you can actually calculate even the time of flight also. So it will go like this, stop somewhere there and come back like this. Or remember, all of this straight line motion is only seen by this guy. In the reality, with respect to ground, it would be some complicated path. Not so complicated, it would be a parabola actually, because this is an effective gravity. I hope you understood how I did this.
Yes.
Okay, fine, good. Next one.
Sir, 20.
2020, okay. A naughty boy is standing at the edge of a roof of a multi-storied building. He throws a ball making an angle T alpha with vertically upward direction. Oh, careful. His alpha is measured with vertically upward direction. Okay. But he loses his balance after throwing the ball and starts to fall at t equal to t naught. Okay, so there is a time delay after the ball has already gone into the air. The ball reaches the ground at t is equal to 10 t naught. Reaches the ground at t equal to 10 t naught, but the boy reaches the ground safely at t equal to 5 t naught. The path observed by the boy is, always remember, boy becomes a projectile, right? Projectile means freely falling body, right? So boy is freely falling between which two instants, please? T equal to t naught to t equal to 5 t naught. So during this period, okay, right, acceleration of ball with respect to boy would be g bar minus g bar, right? Both are g bars, so you subtract, right? So this would be a 0. So whenever acceleration of any particle is 0, it will move along a straight line. Okay, right? So this implies he observes a straight line during this period, and just before that period, that is 0 to t naught, and after that period, that is 5 t naught to 10 t naught, you would see a normal projectile motion. Okay, right? So it should be a what should be the best answer? Always straight line is wrong. Parabola for 0 to t naught is correct, and it should be straight line for this, so this is wrong, and straight line. So I think B is the correct answer. Okay, is that a given key, or did they make any error?
Yes, sir.
Okay, fine, good. Let's move to the next one. Okay, right. In this page, anything? Nothing in that page. Okay, let's move to this one.
Sir, 26.
I thought someone will ask, okay, because it's a beautiful question. Two swimmers moving towards each other. First swimmer is going in downstream while second is going in upstream. Okay, the velocity of the first swimmer in still water is 2, and the of second is 6, and the river flow is 1. Good. When they are 200 meter apart, a butterfly which can fly with a speed of 10 meter per second starts flying from the nose of first swimmer directly towards the nose of the second. Once it reaches the nose of the second swimmer, it flies directly back to the first, and so on and so forth. Okay, so he's asking how many trips does the butterfly make before these two swimmers crash into each other, and option B is traveled a distance of 125. So distance traveled he's asking, and whether the distance is infinite or not in option C he is investigating. Okay, so let's try to picturize this thing first. Okay, still water, river flow is second one is going downstream. So what actually happens is that the first one's velocity, which is downstream, is an addition of this 2, right, and this 1. So his absolute velocity will be 3. This is the first swimmer. And the second swimmer, who is trying to ride against the flow, he will try with a 6 towards left. He will try with a 6 towards left like this, and river will try to oppose that in this direction with a 1. So he will win the fight with a 5. Okay, so this is the picture with respect to ground. Butterfly has nothing to do with the river, so it will go with the absolute velocity of 10. Okay, starts from the nose of the first swimmer. So butterfly is here and moving with a 10. So what is the initial distance between them? The gap between them initially is 200. Okay. Right. I will try to see. There is another one way of doing this problem, which is the long way. I'll tell you how that long way you'd see in many textbooks. There is a interpretation of this question even in Resnick and Halliday. That's why I didn't mark it there. There is a two trains are moving in opposite direction, and there will be a fly which will be moving in back and forth. So if you see the solution manual of these things on the net, there is a way they solve this question. So what they'll do is they'll do step 1, step 2, step 3, step 4 like that. Okay, so first step is for this 10 to meet this 5. Okay, so this 10 will meet this 5 in a time of 200 divided by 10 plus 5. Okay, so this is the step 1 period. How did I write this? Step 1, the distance between the two things divided by relative velocity of approach. Relative velocity of approach of this insect and this second person is 10 plus 5 because they are traveling in opposite direction. This is a school level stuff. Using this time, they will calculate what is the new distance. Okay, and then again repeat that in step 2. In step 2, the insect will try to approach this 3. Then step 2 will have a 10. Let me write that for you. They will be having a 10 plus 3 in the denominator, and this question mark on the distance is calculated in the long way in that particular problem. And then this would be T1, T2, T3, T4, so on and so forth. You'll realize that there is a geometrical progression for this time. So infinite number of steps would be there, right? But the sum of those infinite series of numbers would be a finite quantity because the common ratio would be less than 1. This is a long process which will give you answer as the first one. So it will make technically infinite number of trips. Doesn't mean time taken is infinite or distance traveled is infinite. So there is a shortcut to calculate that time. Okay, time is very simple. I think instead of taking the butterfly or the insect here, you just try to see how these two will meet. Okay, these two will meet irrespective of what butterfly is doing in between, right? So the meeting time of these is related by 200 divided by 3 plus 5. I think this is the T total. It's as simple as that, right? So 200 divided by 8 would be the T total. And in this T total, I think the insect will travel a distance which is with a constant speed, right? So directly, instead of using these steps, you can directly write the distance traveled by the insect as the value of its speed multiplied by the total time. The total time I'll borrow from there, which is 200 divided by 3 plus 5. This is a nice way of, or a commonsensical way of solving the problem much more quickly. So the 2000 divided by 8 is the total distance traveled by the insect, which would be 125 meters. So answer should be B also. Clear? So I hope, but the distance is not infinite. Time is also not infinite. Trips number is infinite. Is this clear?
Yes, sir.
I hope. Yeah. Next one. Anything else in this page?
27.
27. Let's see 27. A train moving with a constant velocity of 70 by 9 meter per second. When a bullet strikes in a direction making an angle of 37 degrees with the train. The bullet enters one compartment at a corner and farthest from the engine, passes diagonally to the opposite this thing. Okay, right. He gave only long and wide. Let's read. So this is how you do it in the exam. Long and wide. It didn't give me what is the height of the thing. So maybe he's only considering a 2D version of the train. Because how I know this? Because he has not given the height. That is his mistake. Okay, so I'll solve it only in the 2D fashion. So I'll draw the top view of the train. It will become a box now in the top view. Okay, right. Long is 2.4, wide is 1.8. So bullet should start here and reach here. It should go off from there. Train is moving with a constant value of 70/9 when bullet strikes. So engine is this side, right? Let's say engine is this side, which means the motion of the train is in this direction. Okay, fine. He never mentioned anything about gravity, so this is like a carom board kind of a thing, okay, where the carom board itself is moving with 70/9. Okay, right. So with respect to the train, it's easy to solve. So with respect to the train, whatever velocity of the bullet is, okay, let's write velocity of the bullet has two components, Vx and Vy. But this green colored thing will be with respect to ground. So if I have to write this velocity in train's frame of reference, I have to reverse this 70/9 and put it on the top of this thing. So this should be 70/9 in reverse direction. Okay, so in the train's frame of reference, this total set of vectors should fight with each other in such a way that the resultant is along this line. Resultant should be along this line. Okay, right. And also when it strikes in a direction 37 degrees with the train. So that 37 degrees with respect to a train is the Vy and Vx direction. So the green color set tan inverse of Vy by Vx is 37 degrees. That is one equation. Second equation is in this resultant direction. Let's draw the resultant direction this way. In that resultant direction, tan inverse of this time the value of Vy divided by Vx minus 70/9. Instead of writing tan inverse, I could have directly written the tan of this thing should be tan this theta, right? What is the tan theta equal to? 1.8 divided by 2.4. So these are the two sets of the equations. So two equations, two unknowns, solve for Vx and Vy, and you should be able to get the required velocity. Is it clear?
Yes, sir.
Yeah. I think time can be calculated by using Vy component because it's easier, right? So Vy should be used to travel this 1 meter. Right. Next one. Anything else? Okay, next page. Anything in this page? (31) no issue. Chasing problem, but 8 particles he has taken. I hope everyone's okay with the option D also. Remember, they are all traveling with a constant speed. Whenever any curvilinear path happens with constant speed, tangential acceleration is 0. Therefore, acceleration has to be normal to the velocity vector. That's what he's requesting here. Okay, so this is a conceptual idea, okay, that I have already discussed in projectile motion. Okay. So we are done with the DPP1. Let's move on to DPP2. putting here in the page of TPP2. Here. Third page.
Yes, sir. 15.
I think in 17th question there was a correction. I posted the picture. Key was given for the reverse of this ratio. I think you might have checked it.
Sir, 15.
I am not able to hear your voice clearly. Can you?
15 questions. One time.
15? You're saying 15?
Yes, sir.
But 15 is similar to that car question in the classwork that we discussed in the lecture. The vertical windscreen is made of two parts, 25. Then the lower part covers 5 centimeters. Here he didn't give the diagram. So its upper part is hinged at upper end, and so that it can be opened outward, right? The car is running on the horizontal road with 20√3. Only difference in my question, it was like both these velocities were same, so we had a 45-degree thing in the rain falling vertically with a speed of 20. So the maximum angle through which the upper part can be opened outward is something, and then he has mentioned this number, right? So is the diagram the issue? Did you attend that class on relative velocity?
Yes, sir. I circled in that down section. I forgot to see.
Okay, actually it's not your issue also, because the way the problem is structured, he didn't give any diagram. It's difficult for you to visualize what is happening. Now I hope you can go back to that lecture and see that question. Only thing is changed is the numbers, that's it. Okay, I think we use the sine rule also after drawing the triangle. Okay. Right, anything else in this page, please? (17, 18, 19). 20.
So 21.
21, let's see. A stone is thrown at an angle of 45 degree to the horizontal. Good. Another stone B is thrown with 20 meter per second horizontally as shown in figure. They collide in midair. If distance BC is 4n meter, further collision to take place, then find the value of n. Okay, so this is similar to your ship's problems. Yesterday they were trying to meet and all that, right? So always sit on one particle and watch the other. That's the best way of solving that problem. So I'll choose with respect to A to solve this question. So I'm solving this question with respect to A, which means for a person who is, or the reference frame who is sitting on A and watching B, he would say velocity of B with respect to A is always velocity of B added to the negative velocity of A. Okay, which means I have to reverse this vector. I have to reverse this vector and place it here. Whatever I get, that is what this person will see. This person will think he's at rest. Always any reference frame with respect to himself will say I'm at rest. Okay, so I'll just reverse this arrow and place it here. Instead of just reversing it directly, what I'll do, I'll split the components and reverse those components. Okay, so you'll all agree that this 10√2 splits as a 10 each in these two directions. So reversing and putting it on the top of this thing is putting this 110 like this. This is for the reversal of this thing. Okay, and this 10 reverse and place it here. It overlaps with this 20 and makes it an addition of 10. Okay, so can I say this is equivalent to having a 30 in this direction? So this is equal to 30 in this direction. So this becomes a 30. And one more important thing, what is the acceleration of one projectile always with respect to other? I think it will be 0 because it's g bar and g bar, which boils down to a problem of a straight line motion. So as seen by A, B should travel with a constant velocity vector, which is a resultant of 10 and 3. This resultant should be such that if extended, so if I extend these two, the resultant of the 10 and 3, if it passes through that A, then only collision will happen, because in this frame of reference, A is at rest. Okay, right? So I'll find tan theta in two ways and equate. One is the velocity way. Tan theta should be that red colored 10 divided by that green colored 30. Can you see that? This is velocity way. But there is geometry way also, which you could see here, right? There is a big triangle here, actual geometry. So tan theta is 36 divided by unknown BC. So it should be also equal to that 36 divided by unknown BC. So you'll get the value of BC is equal to 36 times 3, which is 108 meter. I hope I'm right. Okay, so what did it give the value of n as? N comes out to be 27, huh? Is that the correct answer? Can you check? Or there is a printing error?
They gave 3, sir.
It can't be 3. Did you get 27?
Yes, sir.
Right, I think this is the answer. Okay, anything else in this page? I think this was also some printing error. This was supposed to be pi by 3 radian. I think I marked it, so please check. Let's move on. This was the previous JEE question where they gave 2 answers. Okay, they realized that one of the answers is possible when this value is so small, right? This 0.3 meter per second is so small that it could actually hit it immediately after this. So in second possibility is that this particle stays here only with respect to this cabin because it has accelerated too much, and this 0.2 takes all the time to come and hit here. So if the collision were to happen here, then you'll get the second answer possible. So that's why there should be 2 answers here. In the final key also they made it 2 answers. These are all previous JEE questions. In the last subjective, I have placed previous JEE questions here. Part B of the DPP. I think there were some printing errors in 4th question and 5th question, which I highlighted. Statement and reasoning. Subjective questions. Anything here? These are all very good questions actually from 20 onwards. I picked them from some school Olympiads. Not very tough, but like slightly tricky. Okay. Did you people need more time to finish DPP2? I'm just getting it out because you're not asking any doubt in here. That usually happens in two extreme cases. Either you don't have any doubt, which makes me really happy, and second case is you didn't get time to actually even see those questions. Okay, so do you want me to give you enough time for DPP2 before I take up the discussion? Anyone, you can just reply. It's fine. If you need more time, you'll take more time. It's fine. Okay. So, okay, fine. I'll assume that you have no doubts in this. Let's move on to the weekly planner. Yeah. So anything in this Ashish Arora, illustrative examples or practice exercise on Tuesday? Here, anything that you have a doubt on? Should I open this? If anyone has an issue in any of this, I'll open that book for you people and then you can ask. If you don't have anything in this, then I'll go to the next book. HC Verma, should I?
Sir, I have a doubt in HC Verma. You don't need to open the book. It is just a subjective one. I can read the question out.
Yeah, I kept all the things open. It's not a big deal for me to open it also. So can you tell me the question number?
Sir, short answer is 14.
Okay, fine. So, got it. This one, right? Yeah, rain's falling vertically. A man running on the road keeps his umbrella tilted, but a man standing on the street keeps his umbrella vertical to protect himself from the rain. But both of them keep their umbrella vertical to avoid vertical sun rays. See, the idea of sun rays is that they'll be moving at velocity of light, right? So the velocity of light is so high that the relative velocity of sun rays with respect to man, which is v sun rays minus v man, it's almost equivalent to v sun rays. Okay, so the person's speed can be compared to the velocity of raindrops, which is particles. Okay, but the sun's velocity, right? So sun, or I should not say sun's velocity, the sunlight's velocity is so high that the relative component value addition or whatever you do, it's actually not going to affect the triangle that much. Okay, so that's the idea. I hope you understood what I just said.
Yes, sir.
Okay, that's. So I'll close this. Anything here? Thursday's Ashish Arora. Should I open any of these conceptual MCQs, numerical MCQs, advanced MCQs? Subjective of Ashish Arora book. Okay. Some students requested for IP textbook, so it was only in this particular week, only one page was required. So I posted that page points 1 to 7 in your MS Teams chat section. So please go through them. All the 7 points we have already discussed in the class. It's nice to actually go through them at one place. That's the only reason why I marked these things as a reading. Okay. All right. So I'll take a poll at the end, like we always do, on